All right, and these are basically examples where we want to solve for a specific variable. So circumference is equal to 2 times pi times the radius, and we want to solve for the radius. Well, to solve for the radius, we just have to get this by itself, so we just basically have to divide by 2 pi, and so r is equal to c over 2 pi. And so that's kind of what they're showing here. We're dividing by 2 pi, divide by 2 pi, so r is equal to c over 2 pi. What about this one? Now we want to solve for a. Well, if we want a by itself, we're going to have to multiply by b plus b on both sides. And so that should be our first step. So multiplying by b plus b is what we're going to do. And one way to show it, which is not how they show it here, is they're saying we're going to take a b plus b times that. And when we take that, that's why we have this. And that b plus b cancels that b plus b, leaving us with just 2a. Now we're going to divide both sides by 2, and when we do that, that solves for a. So again, all we've done here is divide that by 2, divide that by 2, and we get a. And so then a is equal to the h times big B plus little b over the 2. All right, what if we want to solve for s? Well, first things first, we have to kind of go in reverse order of PEMDAS. So first thing we have to do is we're going to have to subtract b from both sides. Okay, so when we do that, we get s minus b, and then we're subtracting that. So those cancel, and we have 2s plus l is left. Now we want to solve for s. So what we can do is we can divide by 2l, divide by 2. Maybe I should make an L like that so it looks a little bit better. Well, that's not a very good L either, but that's beside the point. So let's erase that. There we go. And so S then is just the S minus B over 2L. Okay, and so that's how we can solve different types of equations. And again, these can even be more complex than what we've shown here. You know, it could be more complex than that, and especially more complex than that one. And so they could be very, very complex, and we can still just go through algebraically, undo everything until we get to whatever variable they're asking for. All right. So one last one where we have actual application problems. So this one we have to think about how work problems work. Ha, play on words there. So it says a pump can fill a swimming pool in three quarters full in 6 hours. Another one can fill it three-quarters full in 9 hours. How long would it take the pumps to fill the pool three-quarters full working together? Well, now we have to think about how much time it takes for just one part of it. So what we're going to do is we're going to take T divided by 6 in this case, plus T divided by 9 in this case, and it's going to take the full time is going to be 1, so then we have is equal to 1. So that's going to be what we want to do. Now I'm going to do this a little different. I'm going to look and see what is a common kind of a denominator. And I see that if I multiply this by 18, I'm going to have 3t. Here I'm going to have plus 2t equals 18. So I get 5t equals 18, or I get t is equal to 18 over 5, and this is going to be hours. Now, we could rewrite it as a mixed number, and that would be fine as well. We could also write it as a decimal, so that's going to be what, 3 point, I think, 6 hours. And so it all depends on how you do it. Now the book decides to do it a little different. They're going to use 36. Now why they decided on 36, I don't know for sure, because usually use the least common multiple, but they didn't do that in this case. So when you do that way, you get 6t plus 4t equals 36. And so then you get 10t equals 36. So divide by 10, you get 3.6 or 3 and 6 tenths, which then they have to reduce to 3/5. And if you multiply that all out, you get 18/5 also. So this is the same thing as 18/5, which is also the same thing as 3.6. So all depends on which kind of value they want in the end. Now, if they want a mixed number, that would be what it is. If they want an improper fraction, that's what it is. And if they want a decimal, that's what we would have there. Okay. So again, they are going to say they just want it in 3 3/5 hours is fine is fine, is what they want. I would say 18 fifths hours would probably be a more proper one using improper fractions. And if we want to go ahead again, use decimals, 3.6 hours. All right, so that's all I have for this section, so hopefully that helps.